Hello friends, how you doing? And I hope you really all are having a great day and fun time and everything is going smooth. Just remember, you're the captain of your own ship. Sail your ship to the shore, and that is what I pray for you. Yes, today we will talk about some questions from the genetics first chapter, that is principles of inheritance and variation. We will do some 10 questions regarding this chapter. First of all, we will do the questions from pedigree analysis. But before that, let us talk about what is the importance of this chapter and in NEET. How many percentage of questions have been asked? If you see the past 3-4 years, we will just have a quick analysis and then we will start discussing the questions. Okay, so come here, okay, and let us start talking about the analysis of this. So in genetics, there are 2 chapters, right? In genetics, 2 chapters. The first one is principles of inheritance and variation. Principles of inheritance and variation. And the second one is molecular basis of inheritance. The molecular basis of inheritance. Right. Now friends, we all know that in NEET, okay, in NEET if we talk about, there are 180 questions, right? To put more stress on that, in NEET, there will be 180 questions, and out of these 180 questions, 90 will be that of biology, the rest 45 physics and 45 chemistry. 90 biology, 45 physics and 45 chemistry. Right. So we see that this biology holds a clue or holds the key to success in NEET exam. 50% is very, very, very much important. And you already know the scoring system, that for every right question answer you get +4 and for every wrong you get -1. So we cannot afford to do mistakes. Yes, there will be some silly mistakes, but simply, we cannot play the hit and trial method. 1 mark. 1 mark can make you thousands, okay, of rank up and down. Because 1 mark, they say, on an average holds an importance of 25,000 rank, and it's not a joke. Either you're in the game or you're out of the game because of that 1 mark. So this -1 holds a very, very important factor. Holds a very important factor. Now, since we have seen that 50% is biology and we are talking about genetics, let us talk about genetics and let us see how many questions have been asked from genetics in the previous 4 years. So this is the genetics we are talking about. In the year 2014, about 8 questions from genetics have been asked. If we move further up, 2015, we see that around 15 questions have been asked. That is bamboozling. Almost double the number of questions we see in the next year. However, in 2016, there was a certain drip, and the number of questions asked, I'm talking about the main exam, okay, the CBSE and the NEET exam, 13, and 2017, we see that 10 questions have been asked in NEET exam. So, on an average, 11% of biology questions from genetics. This number holds the key. That is 11% of the biology questions will be from genetics. In 2014 they said 8, 15 questions, 2016 13 questions, and 17 10. 11% of the biology questions are from genetics, and we cannot afford to miss these questions. And out of these 70% will be moderate. That is moderately hard or easy, the tough level, and 30% will be hard. So this was the total analysis what we have seen, and we cannot afford to miss genetics when we are studying. Okay, very important. Okay friends, now since we have seen the importance of this chapter, let us come back and let us discuss about the principles of inheritance and variation and their 10 questions. Okay, so we are discussing questions based on the NEET pattern, and we will see the first question. Identify the inheritance pattern in the following picture. What is this? What is this? Okay, before I tell you the solution of the first, let us see the second question. Identify the mode of inheritance. Let us see the third question. Identify the mode of inheritance. The fourth question, identify the mode of inheritance. Fifth question, identify the pattern of inheritance. Finally, we see something else. 5 questions from pedigree analysis. Yes, this is very important. The pedigree analysis is very important because there are maximum chances one question will be from this particular unit, and it won't be easy. See, there are certain laws we have to remember. For example, for a trait to be dominant, it has to be affected in every generation. Like this is the first generation, the second generation, the third and the fourth. But we see here that in this generation the affected trait is absent, right? And similarly, there are the other rules and regulations on the basis of which we will categorize each of them as whether the mode of inheritance is X-linked, as whether the mode of inheritance is autosomal, or the mode of inheritance is what? Dominant or recessive. Yes. So first of all, before starting this question, let me tell you what is this. I have already discussed this in my normal sessions of the chapter, that this is pedigree analysis, and why do we need to know about pedigree analysis. Okay, so let us see some 4-5 questions, let us see some basic facts about pedigree analysis, and then we can further talk about the question. So, this is pedigree analysis, and we will start with we will first see what is pedigree analysis. The study of the inheritance of traits in humans is called as pedigree analysis. It's very simple. So what it is? The study of traits, the study of inheritance pattern of traits. of inheritance pattern of traits in humans is called as pedigree analysis. The study of inheritance pattern of traits in humans is called as pedigree analysis, and this is what we mean by the term pedigree analysis. What else? So why do we need to study human traits in such a systematic manner? Why do we need this? Come back, we'll see a few lines about this. Why we need pedigree analysis. The first reason, the crosses in the human beings are controlled, right? The crosses in the human beings are controlled. And what about the next? The crosses in the human beings are controlled, and secondly, what we will see that here the number of offspring produced won't be too many. Okay, the number of offsprings produced, the number of offsprings produced won't be too many. Okay, so the crosses in the human beings are controlled. We cannot have any cross with anyone. It is a controlled cross, and the number of offsprings produced won't be too many, either 2, 3, 4 maximum, and that cannot extend beyond the limits. And that is why we need the pedigree analysis for humans. Now, before we start with the question, one small last thing what we should know is about the symbols, which I have already told you, and I think you must be knowing it. Sorry. So, what we should know is certain symbols. This is an unaffected male, right? This is an affected, sorry, if you shade this, this becomes what? Affected male. This is what? Unaffected female. Unaffected female. And what else? If we shade this again, this is an affected female. Okay, this is an affected female. Unaffected male, affected male, unaffected female, affected female. One more, two things we have to see. This is what? Mating between the male and the female, right? Mating this is consanguineous marriage, that is mating between the marriage between the relatives, Okay, this I can write as consanguineous marriage. Okay, and what else? One or two last symbols. Which I would like to give you is, say this is mating between a male and a female, and this produces so what we see here, that there is a mating between a normal female and an affected male. Okay, there is a mating between a normal female and an affected male, and this will produce 3 offsprings: a normal female, and an unaffected male. Right? Say, for example, what is this condition? Here what we are seeing, that an affected female is being crossed with an unaffected male, and this will again produce 3 offsprings: unaffected female, affected female, and affected male. So this is what the condition we see here. So in the light of all this, now our homework is done. Now we know what is pedigree analysis. Now we know why do we do pedigree analysis, and what is the significance of it. Pedigree analysis basically, it helps us to know the disease in humans. For example, any condition which can be homozygous or heterozygous, dominant or recessive, autosomal or sex linked, we'll get to know. And if we know that, then definitely we can try, if we know that the fetus in the mother's womb is having a disease condition, then definitely what we can do is we can abort the child if the condition will be too, if the condition is not very good for the child. Okay, so let us now study the first question and let us see what will be the solution. Identify the inheritance pattern in the following picture. Okay. Now, I'll give you some rules based on which you will get to know what are the different conditions. Just looking at it, you can tell it. Rule number 1. If the affected trait appears in every generation, okay, if the affected trait appears in every generation, then it's a dominant condition, otherwise it's a recessive condition. Okay. So, I'll write this here. Rule number 1. If the affected trait or character appears in every generation, okay, appears in every generation, okay, then it is a dominant condition. Then it is a dominant condition. Right. What is the second one? If the affected trait or character appears in every generation, then it is a dominant condition. Otherwise, it will be recessive. Otherwise, it will be recessive. Let us see in the light of this statement or rule number 1 which I have given you, I mean which we are formulating on our own, okay, nothing such rule given as such by Mendel or anyone. It is some rules we are formulating, and based on that we will try to classify all the questions based on the pedigree analysis. So we will see. So which is the first generation? This is the first generation, right? The first generation. This is the second generation. This is the third generation. And this will be the fourth generation. I hope it is clear to you why these are different generations, because here an affected female is, okay, we have not read the question also. Let us read out this one. What we are seeing in the first generation, that an affected female is crossing with an unaffected male. Okay, an unaffected female. Why? Because it is shaded, the circle is shaded, and hence it is an affected female. Here there is a square which is not shaded, unaffected male. So an affected female is crossing with an unaffected male, and this is producing what? This is producing further the, you can see the unaffected female, the unaffected male, and the unaffected male, right? Now what we do, we cross this one, we cross this unaffected male with an unaffected female in the second generation, and this produces the third generation. Okay, all the three again will be unaffected, and then what we see in this condition, that there will be in the fourth generation, again what we see is there will be an affected male, an unaffected male, an affected female, and an unaffected what? Unaffected male condition, right? So now what do we see here? See, in the second generation, a male, an unaffected male was crossed with the unaffected female, and in the third generation an unaffected female was again crossed with an unaffected male, right? Rule number 1 says if the affected trait or character appears in every generation, then it is a dominant condition. It is appearing in the first generation, the female is affected. It is not appearing in the second generation, it is not appearing in the third generation, it is appearing in the fourth generation. So since it is not appearing in every generation, so we can say this condition is what? Is a recessive condition. Okay, I hope this is coming in the same frame. So this is a recessive condition. We know that this is recessive, no more dominant. Now we have to know whether this is autosomal condition or a sex-linked condition, right? So what can be the other criteria to know or what can be the other rule to know the sex-linked and the autosomal condition? So now autosomal or what? Or X-linked, right? Now let us see the conditions for X-linked recessive. For X-linked recessive, rule number 2 applies. And what does the rule number 2 says? What does the rule number 2 says? First point, more boys affected than girls. Okay, the first point, for it to be X-linked recessive, there has to be more boys affected than girls. What is the next point? The next point says that females not affecting females, not affecting females. And the third point, affected mom has to have affected sons, has to have affected sons as well as dad. Okay, so I think the last line could not be seen. I'll write the third point here, affected moms has to have affected sons as well as dad. Right. For X-linked recessive condition, we have already seen Y recessive. Y recessive because the affected character is not represented in every generation. Now we will see whether it's X-linked or autosomal. Okay. So for X-linked recessive condition, or we can simply say for X-linked condition, forget about recessive, for X-linked, more boys affected than girls. Okay. So how many boys are affected over here? We will see. One boy is affected. Okay. And how many girls are affected? We will see that one girl, and here one girl, two girls are affected. So the first condition only is not applicable here. Secondly, females not affecting the females. Okay, the females not affecting the females. We will see here, okay, this is an affected female, and here there is what? Female not affected. Then a not affecting female will be what? Not affected, not affected, right? And here also we will see not affected female, affected female. We'll leave about the second point as this is not applicable here, and the third point, affected moms has to have affected sons as well as dad. So this is the affected mom. It has to have affected sons. Are the sons affected? No. The dad is also not affected. What else we see here? That's it. So these 3 points have to be fulfilled if it has to be a X-linked condition, and we see that right in the first category this is null and void. This does not hold good, so you can simply avoid the next 2 points, and on this basis you will come to a conclusion that this is not X-linked, and then hence it is an autosomal recessive condition. Okay, it is an autosomal recessive condition. Right. So this is my answer for this particular question. An autosomal recessive condition. Rule number 1, for dominancy, if the character is represented in every generation, then it is a dominant, otherwise it is recessive. Rule number 2, if it has to be X-linked, then the more boys affected than girls. The second point, females not affecting the females. And the third point, affected mom has to have affected sons as well as dad. Right? So I hope you are clear with this. Friends, just note this down, and after you have noted down, we will continue with the other questions and we will finish the pedigree analysis. Okay friends, so I hope you must have noted down. So what was the first condition? We saw autosomal recessive condition, and I hope you remember both the rules and the laws given by me. Okay, you can not given by me actually. So let us now talk about, let us take the second question and we will see the condition over there. Identify the mode of inheritance in this particular pedigree analysis. Okay, great. I hope you're enjoying, because you are getting to know the laws and the details. Let us read this question, read this pattern. An affected female with mating with an unaffected male will produce what? Will produce an affected male and unaffected female. Okay. Okay. So what do we see here? In these conditions, I think there is some problem. Okay. So what we are going to see here, that there is an affected female and an unaffected male. Now this will produce the offspring, which is an affected male and unaffected female, and affected male and unaffected female, and affected female and unaffected male. Now this is the second generation, this is the first generation, the second generation. In the second generation we see that this is crossed with an unaffected female, and this will produce the third generation, right? This will produce the third generation. And then we will see over here what we see, that again the unaffected male is crossed with the unaffected female. This is producing the fourth generation, and this is the fifth generation, right? So does the rule 1 apply here? First thing we should check, does rule 1 apply here? You see this here. Here what we see is there is an affected trait. In the second generation also we see the affected condition. In the third generation also we see the affected condition, and hence we can say that this is a dominant condition. Yes. So dominant condition. So dominant condition, as there is no skipping of generation, as the affected trait, as the affected trait is not missing any generation. Okay. So a dominant condition, as the affected trait is not missing any generation, and hence we say that this is a dominant condition. Now let us see whether this is an X-linked or autosomal dominant condition. For it to be, okay, so what are the things we should consider when we first talk about this autosomal or the recessive or the X-linked condition? So rule number 3 you can write. Which applies in the case of what? Which applies in the case of X-linked dominant condition. X-linked dominant condition, rule number 1. Okay, you have to follow here the triple D. Triple D condition. And what is the triple D condition? Right. I'll write it here. The D, the first D stands for what? The dominant condition, right? The second D stands for affected dad, and the last D, the third D stands for affected daughter. Okay, affected daughter. Okay. So the first one is standing for dominant, the second one is standing for affected dad, and the third one is standing for the affected daughter. Right. What can you see here in these conditions? So we can basically say that a dominant condition in which an affected dad will be producing an affected daughter. Okay, hence we can say that here dominant condition affected dad producing affected daughters. Right? A dominant condition where affected dad is producing the affected daughters will be a X-linked dominant condition, DDD, X-linked dominant condition. This is rule number 3. We have seen the dominant condition, now we will see affected dad, you see here, will be producing affected daughters. In fact, you can write here all producing all affected daughters, all, ALL. So the moment you see that, okay, this is a dominant condition, why in every generation there is an affected trait, and here there is what? There is an affected dad producing affected daughters, hence this is what? An X-linked dominant condition. An X-linked dominant condition, this is rule number 3. So what we have talked about so far, you remember rule number 1, you remember rule number 2, and now you remember rule number 3. Okay, friends, now let us go to the third question and we will discuss about the third question. Okay. Now when we go to the third question, what we will see here basically, we are seeing that all these things over here, what we are seeing is there is, let us first study the question. An affected female is mating with an unaffected male. This is producing in the first generation an unaffected female, an affected male, an unaffected male. This is being crossed with an unaffected female, and this will be producing unaffected female, unaffected female, unaffected male. Again, we see here that this is producing what? An affected female which is being crossed with an unaffected male, and this is the result. The first rule or law applies. First rule number 1. So apply rule number 1. And what is rule number 1? Rule number 1 says that is the affected trait present in every generation, or is it skipping generation? Yes, the affected trait is present in the first generation, the affected trait is present in the third generation, and the affected trait is present in the third generation as well. So, since affected trait is present in all the generations, okay, is present in all the generations, hence a dominant condition, hence a dominant condition. Right. So we are done with the dominant condition. Now what all we have discussed so far? What all we have discussed so far? You remember rule number 1 we have discussed this much. Rule number 2 we talked about X-linked recessive condition. Okay, you know. Okay, let us try to try to handle this question. We will not try to handle it since we know it, but let us go accordingly, First of all, rule number 1 should be applied. Yes, rule number 1 applied. Rule number 2, I have said about the X-linked recessive condition, okay, that more boys should be affected than the girls and all those conditions, okay, both the parents should be affected and all that. So since this is a recessive condition and we are talking about what? We are talking about a dominant condition, so this will not apply here. This will not apply here. Let us go to rule number 3. And what does the rule number 3 says? D, and the rule number 3 is for what condition? Rule number 3, it's for a dominant condition, okay, it is for a dominant condition and this is also dominant. And rule number 3, so we can say it is for an X-linked dominant condition. X-linked dominant condition. Rule number 3. So D is dominant, this one is satisfied or this one holds good, it is dominant. The affected dad should be producing all affected daughters. Is it applicable here? Is it applicable here? There is an affected dad, right? This, okay, there is no, this is non-affected, this, no. So the second and the third D's do not hold good, and hence we can say that this is autosomal dominant condition and not an X-linked dominant condition, since second and third D's, okay, do not hold good, that is affected dad producing affected daughters that is affected dad producing affected daughters, hence autosomal dominant condition. Hence autosomal dominant condition. Right. So clear? This is an autosomal dominant condition which we have talked about. Friends, we have done 3 laws, and see, if you remember all these laws, things are going to be perfect. Things are going to be very easy, because it is not, if you know these laws, you will remember what to study and what not to study, how to go about a problem, and what should be the idea behind every problem, the approach behind every problem, and that is the most important thing. Okay? So let us now study the 4th question. Identify the pattern of inheritance in these conditions. Okay? First of all, we should see again the same. Okay, before getting into the laws and the rules, let us see the question. An unaffected male and a female, both unaffected, are mating and producing offspring in the 2nd generation. In the 2nd generation, we see that an unaffected female is being crossed with again an unaffected male, and this is producing 3 offsprings in the 3rd generation. So now we will apply the rule number 1. Apply rule number 1. Right. First generation, there is skipping of the the affected trait. 2nd generation is present, 3rd generation is present, but since it is missing in the 1st generation, it is a recessive condition. Since affected trait missing in 1st generation, so since affected trait missing in 1st generation, and so recessive trait. Right. Now, when we talk about recessive, it can be 2 types, X-linked or autosomal. X-linked and autosomal. Right. So now we have already seen and decided based on the first rule that this is a recessive trait, as the affected trait is missing in the 1st generation. Out of the recessive, it can be X-linked and autosomal. Now we have to see whether this is autosomal or X-linked. So you remember the rule number 2 we talked about. In the rule number 2, we had said, we had given some conditions of the X-linked recessive condition. Okay, what does the X-linked recessive condition say? Apply the rule number 2. Apply rule number 2 now, and what does it say? You remember, boys affected more than girls. Boys affected more than girls. What was the second one? Females not affecting females, not affecting females. And what is the third one? The affected mother, mom, affected mom has to have affected sons as well as dad, has to have affected sons as well as dad. We have already discussed this rule number 2. So let us read the first statement. Boys affected more than girls. How many boys are affected? Here we will see, okay, one boy is affected more, the second boy is affected more, and one girl is affected. So this condition, which is for the X-linked recessive condition, is holding good over here. Then we see what? Females not affecting the females, and affected mom has to have affected sons as well as dad. Affected mom, okay? So there is an affected mom here, has to have affected son as well as dad. Okay, there is no such condition seen here. Females not affecting the females. Again we see females. Okay, so note the second and third condition do not hold good, and hence we say that this is what? This will be not an X-linked, because this is rule number 2 for what? This is, we know it is recessive, it is for recessive condition, and we know it is for X-linked recessive condition. We know it is for X-linked recessive condition. Right? So now we will see, hence, since this rule number 2 is not holding good and rule number 1 holding good, so we will say that is an autosomal recessive condition, right? Hence, this is an autosomal recessive condition. Okay? Can this be seen in the same frame? Okay. Autosomal recessive condition, and you know why this will be seen in the autosomal recessive condition. Let us go to the fifth question now, the last pedigree, and I hope you will be very clear with this, how to go about this. I'll just rub this. So we see here 3 generations very clearly. In the first generation we see that there is an affected male mating with a non-affected female or unaffected female, and in the second generation we see that all of them are unaffected, and hence when we apply rule number 1 we see that because of the missing of the trait in the second generation, this is a what? A recessive condition. So apply rule number 1. As trait, as affected trait, missing, as affected trait missing, hence we can say that recessive condition. Right. Recessive condition. Now what do we see? We see here that how over here in this condition we see that two unaffected individuals, okay, the two unaffected individuals are mating over here to produce a affected individual, that is an affected male. So we can also say that this is definitely a recessive condition, two unaffected. Right from here you can see, okay. Now we have to see whether this is X-linked or recessive condition. Okay, we have to see whether this is X-linked or autosomal condition. Apply rule number 2. And in the rule number 2 says the first point is males affected more than females. Males affected more than females. Here you see that there are two males affected and there is absolutely no female affected. Hence, this will become what? This will become an X-linked recessive condition. Right? X-linked recessive condition. We have done, so we are done. So what is this? This is an X-linked recessive condition. Friends, we are done with these 5 questions of pedigree analysis, which is very, very, very important. I gave you 3 rules, and let us quickly see all those 3 rules, and then we can we will end, we will stop at 5 questions and we will do the next 5 questions in the other session. Okay? The first rule, what we said? If affected trait missing in any generation, then recessive. If affected trait missing in any generation, then recessive. Rule 2 we said about what? Rule 2 we said about the X-linked recessive condition. If it has to be X-linked recessive, then what? Then males will be affected more than females, affected more. Females affecting females. And thirdly, affected mothers will have affected sons and affected dad. Okay, affected mothers having affected sons and dad. All right. Affected mother having affected sons and dad. If either of these is satisfied, then it is an X-linked recessive condition. Either of these is satisfied, then it is an X-linked recessive condition. Any one has to be true. And the rule number 3 for the D, that is dominant condition, and in the dominant condition, the affected dad has to bear an affected daughter. I hope all this is very clear. This is pedigree analysis. If you remember these rules, things will be very clear, and any pedigree chart you will be able to do it, with just a stroke of some seconds. Friends, down this. We have completed 5 questions, and the next 5 we will do in the next session. The time we meet again, a very goodbye from here, from Dr. Ashmeet. Thank you.